Okay, so I just wanted to kind of review our gas laws really quick. We have Boyle's law, which is an inverse relationship between pressure and volume. I have the rearranged versions of the formula here for you. Charles's law, which is a direct relationship between volume and temperature, and I have the other two formulas written down here. And then Gay-Lussac's law, which is a direct relationship between pressure and temperature, and I have both of the new equations here for you. A few notes. Temperatures must be in Kelvin. Kelvin is going to be equal to degrees Celsius plus 273. Also, our pressures and volumes need to be in consistent units. So if your pressures are in different units, you're going to need to use your conversion chart to be able to convert them. And volume is the same thing. So I've written down on here a little note for you guys. 1 liter is equal to 1,000 milliliters, or 1 cubic centimeter is equal to 1 milliliter, which might be helpful for you. Just know that there may be a few problems where you're going to need to convert in order to keep our units consistent. All right, so we're going to look at our first problem here. This is a Boyle's law problem, and it states that a gas has a volume of 300 milliliters at 300 millimeters of mercury. What will be its volume if the pressure is changed to 500 millimeters of mercury? The video is going to pause to give you time to do the solution for this. Type in your answer, and then it will resume showing my answer. Okay, so for this problem, we have here a volume of 300 milliliters, which is going to be our volume 1. We have a pressure of 300 millimeters of mercury, so this is our pressure 1. It wants to know volume, so we're searching for V2, and we've got our pressure 2 of 500 millimeters of mercury. So I'm going to go ahead and write down the equation that we're going to be using, and that is V2 is equal to pressure 1, volume 1 over pressure 2. So this is the equation that we're going to be using. I'm going to go ahead and plug in my units. So pressure 1, we've got 300 millimeters of mercury times 300 milliliters being divided by 500 millimeters of mercury. At this point, our millimeters of mercury are able to cancel out, leaving us with our unit of milliliters. And the answer that you should end up getting is 180 milliliters. Moving on to our next question. We're actually going to come down here to Charles's law. So Charles's law states that a gas has a volume of 4 liters at 50 degrees Celsius. It wants to know the volume in liters at 100 degrees Celsius. So once again, the video is going to pause to give you time to do this problem, and then you are going to come back after you've entered the problem and see my solution. Okay, so looking at this problem, we have our volume of 4 liters. This is going to be V1. We've got our temperature at 50 degrees Celsius, which is going to be T1. And it wants to know our new volume. It's specified in liters, so we're searching for V2, and it gives us a temperature 2. Remember for this one that our temperatures need to be in Kelvin, so we need to convert those. So 50 degrees Celsius plus 273 is going to give us 323 Kelvin for our temperature 1. And 100 plus 273 is going to give us 373 Kelvin. So we have 2 new updated numbers. The equation that we're going to be using for this is V2 is equal to V1 T2 over T1. So we can go ahead and plug in chug. So we're going to have 4 liters times 373 Kelvin over 323 Kelvin. Our units of Kelvin are going to cancel out, and we are going to be left with an answer of 4.62 liters. All right, we're going to go ahead and do a problem working with Gay-Lussac's law. So looking at Gay-Lussac's law, we have the gases in hairspray, or a hairspray can, are at a temperature of 27 degrees Celsius and a pressure of 30 pounds per inch squared. The 30 pounds per inch squared is the same exact thing as PSI. If the gases in the can reach a pressure of 90 PSI, the can will explode. To what temperature must the gases be raised in order for the can to explode, assuming constant volume? So looking at this problem, we have temperature 1, we have pressure 1, and we have pressure 2. We are going to be searching for temperature 2. So we're trying to find temperature 2. Remember, our temperatures need to be in Kelvin, so we're going to take 27 degrees Celsius and we're going to add 273 to that, and that is going to give us 300 Kelvin. The formula that we're going to be using for this one is P2 is equal to P1 times temperature 1, times temperature 2 over temperature 1. So now that we have our formula and we've gotten everything situated, we can go ahead and plug and chug. I'm sorry, we are looking for temperature 2. Geez. Temperature 2 So T2 is equal to pressure 2 times temperature 1 over pressure 1. Now we can go ahead and plug and chug. So we're going to have 90 psi times 300 Kelvin over 30 psi. Our pounds per square inch are going to cancel out, and we are going to be left with an answer of 900 Kelvin, or if you answered this in degrees Celsius, 620 degrees Celsius. All right, let's look at this problem. A gas has a volume of 460 milliliters at 500 millimeters of mercury. What is the volume at 1.2 atm? I'm going to help you guys out just to start this one. We have volume 1, we have pressure 1, and we have pressure 2. You are solving for volume 2. The video is going to pause to give you time to solve this, and my solution will be after shortly. Okay, so now that you've had a chance to look at this one and hopefully solve it, hopefully the first thing that you recognized is that we had atm and millimeters of mercury. One of the first things I told you when the video started, or when the worksheet started, was that our units needed to be consistent. So we need to somehow get millimeters of mercury and atm to be the same unit. You can convert millimeters of mercury into atm, or you can convert atm into millimeters of mercury. I chose to go with atm into millimeters of mercury. So we have 1.2 atm. We're going to convert that to torr, which is 760 torr over 1 atm. From there, we are going to convert into millimeters of mercury. And I ended up getting a value of, 912 millimeters of mercury. If you decided to convert to ATM, your 500 would have given you roughly 0.65 ATM if you chose to go with that route. So now we can go ahead and we're going to put it into our equation. So I've got 500 millimeters of mercury as my pressure 1. I'm going to multiply that times my volume 1, which is 460 milliliters. And I'm going to divide that by my second pressure, which is going to be 912 millimeters of mercury. And that is going to give me an answer of 252.2 milliliters. Let's do another problem similar to this. So we've got a gas has a volume of 5 liters at 3 atmospheres of pressure. To expand the volume to 750 milliliters, what is the new pressure in atmospheres, or what does it have to be? The video is going to pause to give you time. Now that you've done the solution for this, hopefully you recognize that our volume was 5 liters and 7,500 milliliters. You do need to convert milliliters to liters or liters to milliliters. I converted milliliters to liters, so this is 7.5 liters. So we have our volume 1, our volume 2, and our pressure 1. We are searching for P2 in this instance. The equation that you should have been using for this one is P2 is equal to P1 V1 over V2. So at this point, we're just going to plug and chug. So I've got 5 liters times my 3 atmospheres of pressure divided by 7.5 liters. My unit for liters is going to cancel out, leaving me with 2 ATM. Another problem for you. Gas has a volume of 350 milliliters at 45 degrees Celsius. If the volume changes to 400 milliliters, what is the new temperature? And it wants your answer in degrees Celsius. All right, so with this one, your video is going to pause and you will have time to do the work. Okay, so for this one, we've got 350 milliliters. That is going to be our volume 1. And we have 45 degrees Celsius. That is going to be our initial temperature, or temperature 1. We then have 400 milliliters. That's going to be volume 2. And we are searching for temperature, which is T2. The equation that you probably should be using for this one is T2 equals V2 times T1 over V1. At this point, we need to make sure that our temperature is in the correct units. So we're going to take 45 degrees Celsius and we're going to add 273 to that. And that is going to give us a value of 318 Kelvin. So T2 is equal to volume 2, which is 400 milliliters, times our temperature 1, which is 318 Kelvin, divided by volume 1, which is 350 milliliters. Our unit of milliliters is going to cancel out, and we are going to be left with an answer of 363.43 Kelvin. The answer wants to be in degrees Celsius, so we're going to take our Kelvin answer and we're going to subtract 273 from that, and that's going to give us a value of 90.43 degrees Celsius. Very last problem for you. All right, so we have a problem here. You're going to go ahead and read it, and the video will pause to give you time to go ahead and do the correction. Okay, so reading this problem, we have an initial pressure and an initial temperature of 27 degrees Celsius. The temperature is going to drop to negative 183 degrees Celsius, which is our temperature 2. And we want to know what is the pressure, or what is P2 in the backup tank. So we are going to go ahead and make sure that our temperatures are in the correct units. So when I take 27 and I add 273 to that, I get 300 Kelvin. And when I take negative 183 and I add 273 to that, I get 90 Kelvin. So hopefully you made those adjustments where needed. The equation that we're going to use for this one is pressure 2 is equal to pressure 1 times temperature 2 over temperature 1. So when we plug in our values on this one, we have our pressure 1, which is 900 millimeters of mercury. And we're going to multiply that times our temperature 2, which is 90 Kelvin. And we're going to divide that by our 300 Kelvin, which is our temperature 1. When we do our divisions, we get 270 millimeters of mercury for the answer. If you liked this format for the worksheet, please go ahead and leave me some good feedback, make a comment on the assignment, or send me an email. If you did not, also do the same thing, just because I know I was trying something new.